Okay, question 6 says write an expression whose graph has vertical asymptotes at negative 3 and 7 and a horizontal asymptote at 2/3. Okay, well we're gonna focus on the thing that's easiest to get our heads wrapped around, and that's going to be the vertical asymptotes first. So my function is going to be some function of x over top of, well, if I have vertical asymptotes at negative 3 and 7, that means this must be x plus 3 and x minus 7 in the denominator, because that's going to create those undefined terms or factors in the, or anyway, it'll create an undefined expression there at those values there. So that's what I want here. So that's good. But I want my horizontal asymptote to be 2/3. So what I need here is I need the degree of the numerator to match the degree of the denominator. Well, I already know that the degree of the denominator is going to be x squared. Okay? So with the absolute least amount of work that I can put into here, if I just put the x plus 3, x minus 7 down here, I already know when I expand that out that I'm going to get a leading coefficient in the denominator of 1. I don't want that. I want a leading coefficient of 3. So I'm just going to put a 3 up front here. I know that the degree in the denominator is squared, so I'm going to put like the most basic quadratic in the numerator, but I need its leading coefficient to be 2 to match up here. So now this expression right here is going to have two vertical asymptotes, one at negative 3, one at 7, and it's going to have a horizontal asymptote at 2/3. Now all that I really need to do, and this isn't again always a requirement here, but I got to expand that out. So I'm going to get x squared, so let's say 3x squared, minus 7 plus 3 is negative 4 times 3 is negative 12, and then 3 times negative 7 is negative 21, so it's going to be minus 63. And that is the expression that this question is wanting you to arrive at.